Hi guys, welcome to Mr. Cooper's YouTube channel. Before we get started, give me a huge thumbs up and click on the subscribe button. Tonight we're going to look at the recent Year 12 product design mock that you took. It's an hour-long paper, and I've got an exemplar one right next to me that you can see that I've marked. It shows the questions, it shows some answers, and it shows the mark scheme next to it, or the marks awarded next to it. So without any hesitation, let's get cracking. So question number one then, which classification of timbers do ash and oak belong to? So a 1 mark question getting us into this exam. It should hopefully be a freebie there for us. Hopefully you know that oak and ash are hardwoods. Give an application for one of the timbers named in part A. Important one here, you've got to make sure that what you're saying here for the timber is what was talked about up here. So one of them, so either ash or oak. Okay, so make sure you've talked about one of those. If you don't get that, you can't get any marks for this section. So we've talked about here ash being used for sports equipment, because I talked in my lessons about ash being a really good wood for the wickets in cricket, because it can withstand the impact of a cricket ball hitting it. You could have talked about, in the mark scheme, it talks about oak, using it for a coffee table, for example. So then part C, give 2 reasons to explain why this timber is suitable for the application you've named in part B. Now if you've not put either ash or oak for this one here, you'll get no marks for that section. But then you're not going to get doubly negatively marked. You're not going to get kind of marks taken off for getting it wrong twice, okay? So they would give you marks for this one as long as it makes sense, even if you've got this top one wrong, okay? So try and remember to get things like that where it says named in the previous one. Look at what's being named, follow it through, and then let's follow that on as well. So ash, like we say here, absorbs impact well. It's tough. It is shock resistant, which is good when things hitting it. It's not going to damage easily. It's almost rewritten that, but it's nicely worded, so I'll give you extra marks for that. If you'd have said oak for a coffee table, you could have said aesthetically pleasing due to the grain pattern and mid-brown colour, easy to cut with standard tooling such as bandsaws to enable legs and parts to be cut to shape, is a tough material, would be able to withstand items such as TV remote controls being dropped on it, okay, or something similar to that. Excuse me. We then moved on to question number 2. Name a thermoset which can be used for an electrical socket. And thermosets are not affected by heat. For that one, we've got urea formaldehyde, UF, which is your stereotypical one used for plug sockets. Okay, straightforward answer for that one. Not a lot I can say on that. If I flip this over, you can see this one's a kind of lengthy question for rather a simple answer. So match the following pieces of equipment to the correct appliances or applications, shown below. Centre lathe, milling machine, brazing hearth with gas air torch, and bandsaw. You should only use each letter once, so take your time putting this one down. And you can see my exemplar one here, not quite right, but hey ho. Application, then cutting a sheet acrylic into 100mm squares. So we're cutting it with straight lines into 100mm squares, and we're looking for a bandsaw to cut the sheet acrylic. We couldn't use really a milling machine. I guess technically we could, but 100mm is quite small. You know, if you look at my pen, 100mm would be about that kind of length. Okay, a milling machine, yeah, it could do that. There's a lot of wastage going on. It would take a lot of time to clamp it down. It's not particularly that accurate for cutting small amounts like that. Okay, reducing the diameter of an aluminium bar. Yes, we're talking about reducing the diameter. An aluminium bar, solid bar, would go on a centre lathe for that. That's a metalworking lathe. Cutting a 10mm slot in a 50x50mm mild steel block. That is your milling machine. So we're going to mill or cut a groove or a slot. Okay, so imagine a chunk of metal like that. Oh, hang on, let me get my hand right. Kind of like that. We're going to cut down the middle of that with my milling machine. Okay, to cut a slot in there. And annealing a piece of copper sheet. So what was annealing? Well, annealing is heating it up to a cherry red colour and then allowing it to cool. So that's a heat treatment process. Has it gone off? Come back. There we go. Sorry, my screen went blank then. Annealing a copper sheet we do using the brazing hearth with gas and air torch. Okay, so we flick onto that one and then state what is meant by the term hardness, 1 mark. So it's how well a material resists abrasion or scratches. So it's that ability to withstand scratching, wear and tear, wear and abrasion, scratching, surface indentation or cutting. Okay, so straightforward so far. Just kind of easy answers to kind of ease us into this exam. Give 3 reasons why kitchen work surface may have melamine formaldehyde layer applied. Okay, so we're looking for something like hardware and durable, which means it resists scratching and abrasion. Heat resistant with a high melting point, so not affected by hot pans or dishes that might get put onto it. Can be pigmented or coloured or a printed pattern laminated beneath the surface to make it look a bit more attractive, a pattern kind of finish to kind of replicate what you get with like a marble effect or a granite effect, that kind of thing maybe. Good chemical resistant, which allows it to be cleaned with the detergents to keep it hygienically clean. So all that kind of thing is what we call not exhaustive. So the exam board will give us marks for other credit-worthy responses or application described. There should be awarded marks as appropriate. So as long as they're correct, and as an exam marker, I would, if I need to, Google things or check things on the internet just to make sure that what is being said is technically correct and accurate. Next one then. Man-made boards are sometimes used by manufacturers instead of natural woods. Describe the advantages of using man-made boards compared to natural woods. Okay, so we're looking for 4 marks, advantages, disadvantages, that kind of thing. So advantages such as constant thickness throughout the board. So man-made boards are made into 3, 6, 9, 12 millimeter thicknesses. There's no problems with grain where it could crack, where it could dry out at a different rate. There are knots and things like that that would leave it to have weaknesses. It's available in large sheet sizes, unlike solid timber. So 8 foot by 4 foot or 2,440 millimeters by 1,220 millimeters. Not prone to defects such as warping, bowing, etc. So bending, as it dries out, it's going to shift in size. And they're less expensive than solid timber of a similar size. You could get boards made of solid timber that wide, but you'd have to kind of glue them together to build up that thickness. It uses the entire tree, therefore more environmentally friendly. Okay, so there's lots of that nature being used there. So we're not having wastage. It's not using any or leaving any of the bad bits of the tree because it can be chopped up or manipulated in such a way. So 1 to 2 marks per relevant point. Award a second mark where the point is explained. So if you said something and explained it, like my example one here, particularly well written with nice explanation being used there. Number 7, let me just flick over. The image shows an armchair. The chair arms shown in the image could be produced either from solid hardwood, so using something like been highlighted here with steam bending, or from laminated veneers, which is lamination. Laminated veneers, if we think of laminated veneers where we are sticking little thin strips like that together to give us the solid shape, as opposed to steam bending, which would use just one solid chunk of material. Okay, either is very feasible, but we've got to compare the suitability of both materials for the chair arms below. So let's have a look at my exemplar answer. Move my sheet, it's just in the way. So we're looking at only 4 marks here. So a thorough comparison of the stated materials related to the production of the arms of the chair. Responses should make reference to aspects such as relevant performance characteristics of the materials and appropriate manufacturing techniques. So let's have a read of the indicative comments that we've got. Indicative comments are kind of examples or points that the exam board are giving to us. Solid hardwood could be formed into the arm shape using steam bending. The laminated veneers would be glued together over a former and left to dry. So either way, you could be doing it that way. Steam bending uses a single piece of timber and no adhesive, whereas laminating process requires many layers and adhesive, meaning after drying, the arm will need cutting and sanding to shape. Okay, because those layers are going to slip on each other. The use of veneers in laminating reduces the risks of faults in timber, such as knots which might be present in solid hardwood. So you could get a knot in there, and it could lead to issues with it kind of breaking or splitting as it gets bent, whereas the laminations will kind of cover for each other. Excuse me. Solid hardwood is more likely to split or splinter after forming than laminated veneers due to the continuous grain structure. Okay, so it's very, very susceptible to splitting and breaking under pressure. Laminated veneer can be produced more cheaply than solid hardwood by using cheaper veneers in the middle to reduce the material costs. So we talked about having nice quality outer layers, cheaper thin layers, and then the nicer quality on the outside, like I'm kind of demonstrating badly in my drawing there. You make that cheaper by having this core being cheaper softwoods and a hardwood maybe on the outside, thin layers again. Solid hardwood arms might be more suitable for external environmental conditions due to the lack of adhesives. Some wood adhesives, for example, PVA glue, is water soluble, so when you get it on your hands you can wash it and it comes off. That's not good for outside, because if it rains it's going to kind of soften and undo the joint. So you have to use a special kind of plastic glue called Cascamite, is one that we use. It's a mixed glue that sets a chemical reaction as soon as it mixes with water, so it starts to set straight away. You have to work quite quickly with that one. That's Cascamite. If I flick over to number 8, so as we work through these exam papers, you tend to go from the simple one-word answers onto more kind of extensively written answers. So the product shown below has been laser cut and fabricated, so put together. An alternative method is to form it in one piece using injection moulding. Okay, so this is like some kind of little shelf, little bracket, and you can see that it's been kind of finger jointed almost with the little cutout bits, and then slotted together. So we've got 1, 2, 3, 4 parts kind of glued together or fastened together. I've given out a little bit of a hint there in what I said, but we'll slide this up and you can see some of the kind of writing gone on here. The amount of writing you're given there, and my candidate here has gone on far longer, almost twice as much. That would be fine. It's all within the boxes given by the exam board. When they see that a candidate has written more than they expected, it's scanned in also. Okay, because normally it's just that amount that's scanned in, and you can kind of work on it from there. With this, we would kind of see the rest of it. I probably wouldn't be able to click on this area to give it electronically, but I'd be able to give marks up here to highlight that we've got them further down as well. So don't think you're limited totally by the amount. I wouldn't go over the page. I certainly wouldn't write in the margins, because that tends to not get scanned. So we're looking again, including detailed analysis, and compares the two processes in detail with relevant or reference to factors such as ease of manufacture and use of materials. The response provides detailed evaluation of the suitability of each process to fabricate the acrylic part. Sorry, I laughed then because my dog came up and sniffed the paper. He just walked into the room. I thought he was going to put his head under the camera and say hello to you. That would be 5 to 6 marks. Indicative comment again comes on. So fabrication method, laser cut and joint with solvent cement. Each component would be accurately cut out on to an accurate tolerance. The tolerance is to within certain sizes. So using the laser cutter would be almost exactly repeatable to within a fraction of a millimetre each time. Doing it in any other way, by hand, would be very, very difficult to replicate that tolerance. It provides a flat, smooth surface that can then be joined. The laser cutting process would provide a reliable, repeatable manufacturing process. The design could be fairly well tessellated, so we could put these out and save kind of material on a sheet to reduce the volume of materials used, although waste will be created. There's bound to be some waste in the design like that, where you've got triangles and other shapes being formed, little cutouts, etc. Laser cutting the design would be appropriate for small flexible production runs where we want to change numbers, and not many of them. You'd be talking tens maybe. The shape provides ample surface area for joining with a solvent cement. The shape of the component means no gluing jigs would be necessary, so it would hold together nicely you could prop it up against something to help it kind of stay in shape, and it's probably self-holding, to be honest with you. Anything. My screen keeps going off. We'll see how we go. The solvent cement we use is quite nasty, so we've got to take into consideration some kind of PPE, some ventilation, some masks, etc., to make sure that we are taking our health considered there. Redistribution method or injection moulding. Component would be a one-piece moulding, therefore require no assembly, so you'd save time on it like that. The size of the component means that several could be easily moulded simultaneously, increasing the volume of production. Redistribution means that the material can be used more efficiently with little or no wastage. So injection moulding is very good for that, so it can be reused, it can be any waste that comes out can be then remelted and put around again. Okay, so it's used up all the waste. Large volume of products would need to be required to justify the expensive initial setup cost of the mould manufacture. So thinking about injection moulding, the machinery is phenomenally expensive. We're talking tens, if not hundreds of thousands to buy a big injection moulding machine. But the moulds themselves can range anything. Well, we had a small one in school that cost about £20,000, and that was 20 years ago. So they're phenomenally expensive. You've got to justify that price, or kind of match that price with the amount that you're going to be making. So it's mass produced, or large scale batch production, mass production. Okay, so that list I've given you, not exhaustive, again, accepted any other reasonable responses. Flicking over, quite a nice one, this one. Explain why cedar, which is a softwood, is commonly used outdoor for cladding, such as an example shown in the image below. Cedar clad property is quite popular, particularly around Ashby where we are. It gives a nice kind of silvery grey finish once it weathers. It starts off quite a yellowy orange colour. Just have a drink, excuse me a moment. So if we look at this one again, a detailed explanation of why cedar is commonly used in outdoor cladding, with a wide range of appropriate justifications that may include aesthetics, working properties and suitability for the cladding context. 5 to 6 marks. So cedar is a quick growing softwood, so very sustainable to use in building applications. So once cut down, we can replant it and regrow it quite quickly. Sustainability and the environmental impacts used plays a significant role in most planning applications. So if we're going to alter the shape or the size, the facade of these houses, we're going to need to put in for planning permission, and the application would talk about the materials being sustainable. It would also make it a lot easier to get through that planning application. It has an attractive red-brown coloration when installed, and it becomes weathered. It changes to a grey-silver coloration, chosen by many for its aesthetic qualities. So very nice to look at. Starts lovely and it kind of weathers really nice as well. Excellent insulator of both sound and heat, as such makes it suitable for material to clad the exterior of buildings where heat loss and acoustic considerations are factors. So if you want to keep the noise in and keep the heat in, then cedar is a very good way of doing it. A natural way of doing it, that we're not kind of using energy inefficient processes to get a material for. Okay, so 6 marks there. And the question I think some of you struggle with in the Unit 8 that we did, explain the benefits of using pressure treatment for outdoor furniture, or wooden products should I say. So if I look through what the mark scheme says here, we're looking for, fungicides or pesticides can be added during pressure treatment to reduce the susceptibility to fungal or insect attack. So we're putting stuff in there that will stop that fungal attack or the insect attack from happening. Pressure treatment makes timber products resistant to rot or water damage, reducing the need for maintenance. Pressure treated timbers have an increased impact strength. Pressure treated timbers are normally supplied with a quality guarantee, provide customers with reassurance that the product will not need to be replaced at significant cost. They don't absorb water, so products such as fencing panels will not need a finish to be immediately applied. Okay, so again, any of those or a combination of those to give a detailed explanation of a number of benefits of pressure treatment for outdoor wooden furniture. Responses demonstrate excellent knowledge of how pressure treatment improves the performance characteristics or prevents degradation, so degrading, with relevant examples to support the explanation. Fence posts, fence panels. I can remember soaking fence posts in a bucket full of pressure treated, or almost pressure treating, by soaking it in that material so it absorbs the fungicides, etc., to stop that kind of thing happening. Okay, but fence panels would be pressure treated, where it's forced in under pressure. And then last few questions. We've got, to which group of polymers do polyactide, PLA, which is our 3D printing material, and biopol belong? They are biodegradable or compostable polymers. Okay, biodegradable, so it's going to break down naturally, or compostable, so we could put it outside to break down, for example. Give an application of one of the polymers named in part A, and again, remember, you've got to name one of the ones that they've talked about, so we're either looking for polyactide or biopol up there. Okay, so we've got down here PLA. What's it used for? Disposable items such as disposable plates. Brilliant. So food packaging, detergent sachets, so where we're talking about the dishwasher or washing machine sachets, so they're going to kind of wear away with water. Surgical stitches, they dissolve on their own now. Plastic bottles that are going to break down. Plastic bags, cutlery, except any references to 3D printing. Let's have a look. Application. Give 2 reasons and explain why this polymer is suitable for the application that you've given. So, sorry, gone to that wrong one. Part 2. Food packaging has a short life cycle. It might go to landfill, and therefore, to protect the environment, such polymers need to biodegrade. For example, PLA can be made into films to make plastic bags to contain food, or biopol can be blow molded to make bottles to contain food products. Okay, so then it breaks down naturally. It doesn't take those 400 or 500 years that plastic traditionally takes. And again, you're not going to get double negatively marked. So if you get the first question wrong, you've not chosen PLA or biopol, you're not going to be marked for that. Sorry, my screen goes blank again. Question number 12, let's just flick over. State 2 safety precautions required when joining acrylic using tensile cement. Now, tensile cement gives off dangerous chemicals like we've hinted at here. It is carcinogenic, so we're looking at a more safe version of tensile to use in school, which I've found called Tensile 1200. Our traditional one's called Tensile 12. It's nasty smelling. It just comes with lots of health issues that we don't want to take any kind of chances with. So we're looking at other ways of doing this. So indicative comments again. Good air ventilation is required to ensure that there's no build-up of fumes from the adhesive. It gives a bit of a high. It's quite noxious, quite nasty, headache-inducing kind of fumes. Tensile cement must be used away from any heat sources due to the risk of ignition. Appropriate PPE, such as latex-free gloves, eye protection must be worn, as tensile cement is an irritant. Read and follow instructions on the packaging. So again, you've got to do as it says, and a lot of accidents, a lot of problems are caused where people cut corners by doing it as they think suitable. But wearing goggles because it's an irritant, one of the 4 problems that we deal with COSH, care of substances hazardous to health, are ingestion, so swallowing it, inhalation, so breathing it in, skin irritation and eye irritation. So if you can kind of cover all of those, then you're going to be onto a winner there. Again, not in exhaustive commentary there. Other credit-worthy responses would be awarded and marked appropriately. So the paper, I believe, was out of 50. A decent score there. We're looking kind of over 30, 35 to be a really good score. Pushing 40 to be an 80%. We're looking very, very high level score in there. Okay, I hope that helps. What I do personally is go back through this. If you if you're struggling sleeping at night as well, listen to me droning on for 25 minutes should help you. Go through your paper, add marks to it, add kind of commentary. Where have you gone wrong? Add that detail that we've talked about that I've gone through there with you. Feel free to write on this. Write on it in a different colour so you can see where you've changed it. Put this into your folders though, and store it under tests or examinations. We've got our units, we've got our end of unit tests. We've also got these kind of in-class assessments that we need to record in there as well. Okay, hope that helps, guys. Take it easy and I'll see you again soon.